Okay, so the first thing we're going to do is we're going to go over a few properties that we can use for the reasons sometimes in a proof. And the first one's called the transitive property. And it's kind of a lot like substitution too. Basically it's saying if A equals B and B equals C. So essentially the important thing here is that they both equal B. Then if they both equal B, A and C both, then A has to be the same as C, which makes sense intuitively if you think about it. Okay, the next one's going to be used a lot in triangle proofs. It's called the reflexive property, and it seems useless and a little specious and pretty obvious, but it actually is very helpful sometimes. It says that A equals A. Something is equal to itself. And this comes up a lot when you have a bunch of sides or angles that overlap each other, like this diagram. In this diagram, you can see that this side, this diagonal of this rectangular square here, is congruent to itself, which can be really helpful if you're trying to prove that this triangle is congruent to this triangle right here. And the last one we're going to use today, we also used it yesterday, and we used addition and division and multiplication, things like that too. But we're specifically going to look at subtraction for one of the things we're doing today. So if you start with like A plus B equals B plus C, you can subtract away the B on both sides, and you're left with A equals C. So right here we have a few statements and reasons, and we're just going to fill in some reasons that we did from before. So this first one says that angle MCU is congruent to angle MCU. So if something's congruent to itself, that's always the reflexive property. And it's not the reflective property. A lot of students think it is and get the CT in there and think it has something to do with reflections. It doesn't. Reflexive property with an X, it just means something's congruent to itself. Okay, so if we look down here, we know that A plus B is equal to 90 degrees and B plus C is equal to 90 degrees. If they both equal 90 degrees, that means we can set them equal to each other, like this. That right there is the transitive property. All right, and finally, we're going from this statement to this statement. What seems to have been cleared away is these angle B's on the left and right side of the equal sign, like they've been subtracted away. That's just subtraction. All right, so what we're going to do right now is we're going to do the proof that all vertical angles are congruent. So in this case, what we want to prove is that the measure of angle A is equal to the measure of angle C. And, we're using A and C here. We're not using numbers, because if you just use letters, that keeps it general and means that it works for all situations. So like this doesn't have to be like 55 degrees. This can be anything, and it will still be equal to C. So let's look here. The first statement we have written says that the measure of angle A plus the measure of angle B equals 180. Well, I know that A and B are linear pairs because they're next to each other and they make a straight line. So the reason behind this is that linear pairs are supplementary. So like A and B right here, they form this line, and that has to equal 180. So the next statement says measure of angle B plus some other angle equals 180. Obviously, we're not going to use angle A again because we already said that. So like that really doesn't help us. That's not very important. But if you look, angle B is also linear pairs with angle C. So these two would have to equal 180. So right there, we can just write measure of angle C. All right, and the reason behind it, we just kind of mentioned it briefly, is that B and C are linear pairs. So linear pairs are supplementary. And there we go. It's the exact same reason as above. I actually literally copied and pasted it. So, yeah. All right, so now we know that A plus B is 180 and B plus C equals 180. They both equal 180. So that means we can set A plus B equal to B plus C right here. So that would be the measure of angle C. And then finally, we can subtract something. What we can subtract from both sides is this angle B on both the left and the right. And what you're left with after you subtract that is that the measure of angle A is equal to the measure of angle C. Or, to look at it a different way, exactly what we were trying to prove. So no matter what these numbers are here, this angle A is congruent to this angle C.